class! Welcome back to Calculus 251. We are on 2.2 of a derivative at a point. And today our appetizer is going to review of what was a derivative. So what was a derivative, class? And we also, we can find derivative, we say that the function is differentiable. What does that mean? So in order to understand derivative, we have to understand rate of change, and we say what is the rate of change? Rate of change is f over a plus h minus f over a over h. That is rate of change. Then if you taking limit of the rate of change, it becomes instantaneous rate of change, which is same thing as a rate of change. And after this one, I like to take the limit and h goes to 0, then that becomes our derivative. And derivative is actually function as I show. So we actually found the function. We will see again today. And with the function by plug-in, you can find the slope at the x value each time. So that's a very powerful statement. So if you keep listening the explanation until you understand. So now I like to explain in graph way. What does a graph way of the derivative? So first like to find the rate of change. Then rate of change means we have to have a two coordinate. So we have, here's a value a as an x, and then this is a plus h because that's h of time passed. So we have a two coordinates, a through a plus h. Then average rate of change means we finding the slope of a given 2 points. As we explained the other day, a and a plus h, you can have a plus h minus f of a plus h, and this is going to be a comma f of a. If you put into slope formula, y2 minus y1 over a plus h minus a into slope formula becomes rate of change. So from 2 points, in order to have instantaneous rate of change, which is we say as a velocity, then instead of having 2 points, we are going to have 1 point. Why? Because we had a and we had a plus h. However, I'm making h small enough that second point is so close right next to each other that almost it's gonna look like illusion of one coordinate because h is going to 0. They're right next to each other. So almost look like just as a one coordinate. So I made a two coordinate to one coordinate by putting my line getting closer to my a value. That is the explanation of the derivative. So now I can find the tangent line, which means at this moment my tangent line is going to be here. At that point, my tangent line is going to be here. So by finding tangent line and by finding each derivative at the point, we can understand the speed a little bit better. Okay. So although we repeated this a couple of times, I want you to fully understand. That is the highlight for our calculus class. And then now let's go back to the definition of a continuity. So what was the definition of continuity? Continuity means I have to have my limit when f over x goes to c, then at f over c has to be, f over x has to be same as my value of the function at c. So basically saying that my limit and then my function has to be the same in order to continue. That means we don't have a hole over there because it's filled in by my function. That's the definition of continuity. And then what does limit exists means? So limit exists means at that point when x approaches from a to the minus f of x, and then limit of x approaches from a plus and f of x, left hand limit, right hand limit, it goes to the same number, then we say that limit exists. If limit goes to infinity, we say that limit do not exist. So remember that. This limit exists doesn't have to do anything about the function of the value going to c. So this one, it doesn't matter you have f of a in this value. It doesn't have to be perfectly continuous, still you can find the limit. So that was a little bit review of our appetizer. So let's continue our appetizer 1 with the below graph. Let me remove the board quickly. So our first appetizer, we are going to go back to our graph, but this time instead of finding average rate of change, I like to find derivative, which is going to be instantaneous rate of change. So let's briefly graph this one, and then let's try to find our derivative function roughly. So linear equation, I have function y is equal to x, and second equation, I have, make sure that you can graph very carefully so that we can see our value nicely. Okay, so I graphed, and then we are going to find the derivative function. How do we find the derivative function? That's going to be rate of change. I have to take the limit h to 0. So let's plug into rate of change into this function, which is f over a plus h minus f over a over h. So if I plug in here, it's going to be a plus h minus x over h. Then, oh, the x is actually a, right? So that becomes a 1. So my rate of change function becomes 1. What does that mean? Look at now, I want you to tell me, last time we talked about what is the slope from 0 to 1. The slope between 0 to 1 is, as you see, 1 here. How about 1 to 2? That's also 1 here. How 2 to 3? That's also 1 here. So what is the rate of change of a linear function in this case? Everywhere it becomes a 1. Is this a function? Yes. How does so? Because now I can graph all over here. My slope is 1. Even they say what is the point, what is the, we can actually find the slope exactly at 1. And this one shows everywhere it will be 1 no matter what, all real values. So I can actually graph my derivative function, which is y is equal to x, or we can write it this one, f prime x is equal to 1, because a derivative function. Call it a derivative function. Then I like to do y is equal to x squared. Y is equal to x squared. Let me use the room here, right side. So same idea. I like to change into rate of change. So we have done many times. I want you to do it as well. So function is y is equal to x squared. Then let's plug in rate of change. F of a plus h is a plus h squared minus a over h, and then limit h goes to 0. So I'm going to skip some steps what I see 2ah plus h squared over h. I already cancel out a squared and a squared there. Bad mistake. And then reduce by, I cannot plug in 0 yet because denominator is 0, but cancel out by h. I'm gonna have 2a plus h as limit goes to 0. So what does that mean? This goes to 0, then I get 2a, which is actually 2x, because derivative function we have to change to x plus h minus f of x. Basically same thing. I just put a because I don't want to get confused with x. So what are they saying is, I found the function. Now let's think about before what we have. So before, when we analyze what the slope here in previous section, we got 2. How we got 2 there? Because we, by observing, plug in left side and right side. Here's 1, here's a 3, and then by IBT we could guess it's gonna be twin there. And also we use numerically by plugging points and then finding around numbers. Also another way is going to be, now we can find derivative function. 영어, what does that do? Well, we found the function. This has a derivative function, looks like 2x. Now I can find my slope everywhere. That means my slope at 1 is going to be 2 by plugging, which we saw that previous section. Then now I want you to find what's the slope at 2. Then if I plug in 2, this slope is actually 4. Then what is the slope at 0? Keep plugging this function. That will give me each slope each time. Plug in 0 gives me 0, negative 1 gives me negative 2. So actually I found each value at that, each value of a slope at that x value of each x value. So I want to put them together if I can graph it. So at 0, my slope is a 0. At 1, my slope is a 2. At 2, slope is a 4. At negative 1, slope is a negative 2. Negative 2, slope is a negative 4. When I connect it, it becomes a linear equation. When I connect my slope, it becomes a linear equation this time. And what is this equation? Which is, you see, 2x plus 0. I see that function as a 2x. That's the same as your derivative function. So once you find the instantaneous rate of a change, which is derivative, after you find the derivative, now you can find the slope by plugging, and that will tell me each of the values. Isn't it cool? Okay, I hope that you understand this part. So now I want you to try in class activities. I want you to pause the video, find the rate of a change each. I'm going to remove and then show your work here. I want you to do another one, rate of a change over this one, rate of a change over this one, and then let's compare if you can find your derivative function. And then after that, we are going to find tangent line at x is equal to 1. So let me explain with this one. Now, I almost done here. Sorry about coming back. I want to find the tangent line at 1. What does that mean? I want to find the point. I want to find the equation. I want to find the equation of this guy, which means passing through my x squared function and passing through 1, 1 here. That's what they're saying. Find the tangent line at x is equal to 1. How do we find it? How do we find it? I know already slope is 2, so y is equal to 2x, and then it's gonna be passing through 1.1, so I can put it to point slope form. That's my equation, right? Y is equal to 2x as a slope, and then transformation 1 comma 1, 1 comma 1. So if I organize nicely, then that's going to be minus 2x plus 1, so it becomes negative 1. So what is my tangent function at 1? I can say y is equal to 2x plus 1. That's the answer for 3. Okay, so try next 2. And then I will come back to you. Do rate of change first. This is not going to be easy. So let's check the answer of the in-class activities 1. I hope that you get to find the rate of change. My rate of change of the number 3 cube function, I got 3a squared. The work is shown here, and then you have to FOIL this one 3 times carefully, then you will get this one. So I got 3a squared. So the derivative of this function turned out to be 3a squared. What does that mean? Now we can find the slope between 2 to negative 1. So at 2, what is this slope? If I plug in 2 here, 2 times 2 times 3, it will show me that my slope is going to be 12. Then, how about slope here? Before with linear quadratic equation, we have a 2. So since this one is a cube, I expect it a little bit more bigger than that. So if I plug in 1, I get the slope at this point is going to be 1. Then how about at 0? What is the slope? If I plug in here, then slope is going to be 0. No, it doesn't look like it. Well, you have to also take a limit when they go very close by this part. If you zoom it again, it's gonna look like this way. Whenever you close your window to like 0.00001 to negative 0.00001, then it's gonna almost look like a flat. So slope 0. How about negative 1? What is this slope? 3 or negative 3? It's 3, positive slope, right? And then when you have negative 2 by plugging, you're gonna get slope 12. So now I can find the slope each time, which we call as a derivative, speed, instantaneous velocity, and tangent. There are lots of names. So I wanna find tangent line at x is equal to 1. Slope is 1. Oh no, slope is 3. I made a mistake again, right? When we plug in, slope is 3. Very bad mistake. I keep making it. And the point that passing through is 1, 1. So what is this equation? I can write it y is equal to 3x as a slope. And transformation y minus 1 is equal to 3, x minus 1, which shows that passing through 1, 1. Let's rewrite equation mx plus b, then minus 3 plus 1 makes minus 2. So my tangent line at 1. Tangent line at 1, this equation is going to be 3x minus 2. And later on, why do we have to do this? Some of the function we cannot graph it, then we using the tangent line to guess. Some function I do not know what their value over here, then I'm gonna put tangent line and then I'm going to estimate it as this value. So that's what ancient people like 17th century, how they find the equations of the function, the graph of the functions. So that's one of the way. Let's look at one more here. So this is going to be radical function square root of x. Did you get a chance to do rate of change? And did you get the same answer as me? I got 1 over 2 times root a as my derivative function. Look at my work carefully. I multiply conjugate. Then I want to find the slope between 2 to negative 2. So all I need to do is plug in here. If I plug in 2, then what is the slope at 2? What is the slope at 2? That shows when I plug in 2, it's going to be 1 over 2 square root 2. Then that was a little bit hard one to fill. So I want to find the slope at 4. Then anybody see? I see that my slope is going to be 1 over 2 square root over 4 is 1 over 4. So this slope is 1 over 4. but we like to find the slope at 1. So if we plug in 1 in here, then what is the slope at that point? I see as 1 over 2. Then what is the point passing through? 1 comma 1. So my equation will be y minus 1 equals 1 over 2x minus 1. So solve it carefully, mx plus b. That will make minus 1 over 2 plus 1 will make plus 1 over 2. So if you see it, do you see that passing through? 1 over 2 is a y-intercept, slope 1 over 2. The tangent line at 1 is going to be this guy. And of course, tangent line at 4 will be different because your graph has a different slope. So you have to find another point for this one. Okay? So this was the main, we are going to keep building the idea of the main dish. So I hope that that was a good appetizer. And let's continue main dish now. So class, let's continue main dish of the 2.2, and we are going to study a little bit more about tangent line, which means derivative function, and they are all related to rate of change, instantaneous rate of change. That means instantaneous velocity as a speed. So let's make our equation a little bit harder than previous one, and then we are going to follow same format as well. So I wanna find the equation of a tangent line of the parabola at x is equal to 2. What does that mean? Do you think can we graph this one? Let's try to graph together. So if I wanna graph a given function, I see here that can I vector as x minus plus 3, x minus 1. So y-intercept minus 3, 1. And then I want to see if we can find the vertex. So vertex you can find two ways. Actually, I want to find vertex using algebra. Do you guys remember? Negative b over 2a as the equation. So if I plug in negative b over 2a quickly, which is going to negative 2 over 2 times 1 gives me negative 1. So that's going to be my x value. So my x value is a negative 1, and then plug in here negative 1 plus 3, negative 1, negative 1. That gives me negative 2 times negative 2 as a positive 4. Negative 1, 2. And then negative 1 is going to be negative 2. So negative 4. So I get my y-intercept, negative 1 and 4. So I can graph here. So what's going on? I want to find the tangent line at 2. I want to find the equation of this red color. Then in order to find this line, as you see, we have to find the slope, and then we have to find point. Point is we already found it. If I plug in 2, that will give me, let's plug in 2 here, 5 times 4. So my graph may be totally wrong, of course. So if I plug in f of 2, what do you give me? 4 plus 4 minus 3. Oh, that gives me 5. So it will pass through 2 comma 5. Let me double check. Yep. So it's gonna pass through 2.5. So all I need to find is a slope by using rate of change. So let's try plug into our rate of change. Now I'm going to plug in my rate of change. We actually haven't used a plus h minus f of a over h, which is actually same as f over x plus h minus f over x over h. Now I start changing to x. Earlier I changed to a was students get confused with some of the x values here. So let's plug it back. Either way is fine for me. You can do whichever, it's fine. So f of a plus h part. Because if you do x, it's gonna turn out to be 1 time just nicely. So let's plug in my function. It's gonna be some tedious work. X plus h squared plus 2 times x plus h minus 3. That's this part I plugged in. Minus, next one is going to be x squared plus 2x minus 3 over h. Okay, I need more room, so let me expand this expression. X squared plus 2xh plus h squared plus 2x plus 2h minus 3 and minus x squared minus 2x plus 3 over h. Okay, almost there. It's a little bit long work, but I want you to try. A lot of them will cancel out, as I said. And then nicely h term will remain. So I'm gonna factor out by h, then I have a 2x plus h plus 2 over h. So I need to send limit here. Oh, not yet. My rate of change is going to be 2x plus h plus 2. Then what is a derivative? Derivative means I'm taking limit here, h goes to 0. So this time it shows as derivative becomes 2x plus 2. We write it this way. That's the derivative of the original function notation. Then what does this do? Since I found the derivative function, I found the slope function at 2. So by plugging at 2, although my graph is off, let's plug in at 2. What do you get? F derivative 2 gives me 6. So I found my slope is a 6. Yeah. Found slope is a 6. Then while with the equation, all I need to do is plug in y is equal to 6x, and then passing through point y minus 5 is equal to 6 times x minus 2. Then Miss Choi like to have mx plus b form. So let's organize this equation a little bit nicely. So that will be y is equal to 6x minus 12 plus 5 gives me negative 7. So tangent line at 2 is 6x minus 7, which means if I graph this one, 6x minus, it's gonna passing through this point. Looks like it, right? So yeah, we found tangent line y is equal to 6x minus 7, which we call as a tangent line. Okay, tangent line. So I got the tangent line, how we find the tangent line. So I want you to look at big picture. First, rate of change. And then after you send in limit, that gives it derivative function. So I can find the slope everywhere I want. And the passing through the point 2, 5 by plugging my value function, then I got tangent line. Okay, now why derivative is so important? This is another material we are going to study in chapter 3. So I'm gonna embed it a little bit. So if we have tangent function, which is we have derivative function, I keep saying tangent function. This is a tangent function and this is derivative function. This is derivative function And this is a tangent function, tangent line. And tangent line. So why is that important? Earlier we found the vertex of -1, -4 using our algebra material. But now we can find vertex using calculus using the derivative function. Why? Our derivative function says 2x plus 2 is the slope. Then think about what is the slope at vertex. Do you guys see that slope at vertex, since it is the minimum point, the lowest point, it is a very bottom value, bottom of the ocean. So in this part we say slope is 0. That means I want to set my slope function, derivative function is 0. Can you solve for x here? So move, and 2x is equal to -2, x is equal to -1. So, I found my x value. When it is -1, I'm going to have minimum value. Why? Because the slope is 0 here. When you see, this is a slope 6, this one will be slope -6. By, again, IVT, intermediate value theorem, in continuous function, I had to pass through value 0. There's no way that you can pass from -6 to 6 without going through 0. So I have to have a slope 0. When is it going to be? And when x is 1, that's going to be your vertex. So I found the x coordinate by using calculus. Then by plugging -1, then you will get y value -4. So I can find same vertex using calculus. Isn't it cool? Yeah, right? So calculus is actually really fascinating. All the math you learn in your last 12 years will explain why in calculus class. So keep studying with me. So as you see, there's in-class activities, one more question. I want you to do exactly same. And pause the video. It's going to take about 5 to 8 minutes. So spend your time and compare my answer. But this time you want to find your slope at x is equal to 3. Good luck and compare with me. Class, I want you to see if your in-class activities matches with me. Let's compare the answers. First, I got the rate of change 2x plus h. And if I want to find the derivative, by sending h to 0, I get 2x minus 8 as my derivative function. Make sure you write it in f. Derivative function of x is 2x minus 8. So what is the equation at 3? So I briefly, using the algebra, plug in negative b over 2a, I found your vertex so that we can graph. Let's graph briefly here. So my vertex is 4, -7 about here, and then my function is gonna kind of look like this way. Oh, it's gonna go more because I see that y-intercept is 9, and then that's going to be 4, -7, and symmetric here. So what I wanna find is I wanna find the equation at 3. Did you notice that at 3 my slope is going to be negative? So I'm going to plug in 3. So if I plug in 3, do you guys see that at that moment the slope at 3, when x is at 3, slope is going to be -2. I plug in 3 here, then 6 minus 8, I got slope -2. Then I need to find what is this coordinate. By plugging 3, and then y value gives me -6. So I can find my function one by one. Y minus -6 equals -2 times x minus 3. Okay, so far, are you guys understanding? Okay, y is equal to mx, which is -2x, and then this towards the transformation coordinate -6 and 3 and -6. So by solving for y, it's going to y is equal to -2x plus 6 plus 6 minus 6. So I get actually y is equal to -2x. That's it. That means my function is gonna pass here. This is my tangent line at x is equal to 3 of my x squared minus 8x plus 9 function. Then what is the vertex? As we can find from the derivative function said 2x minus 8 is my derivative function. Then I wanna see vertex means when my slope becomes 0. As you see, your answer is 4 because we already found it. But if I do not find this one, you don't even need to do this one. From here, I'm going to set equal to 0. Then, do you see that your x value has to be 4, right? And since it is a function, plug in 4 into my original function. Then that gives me -7. I did it earlier quickly so that I don't spend too much time. So plug in and I got my vertex as 4, -7. So now if you want to graph, you don't have to use any more vertex formula. Just to continue from your derivative function set equal to 0 because any point when you have maximum or minimum, we're gonna say as a critical point later. And those times we are going to have a slope 0. So at the critical point, you can find your maximum value, minimum value. They are related to your vertex. Okay. If you look at now your page number 2, page number 3, actually I put in class activities 3 more questions. So very similar format as what we did, and I want you to answer one by one and try next 3 and then compare answer with me. This time now I want you to make it yours. We've been explaining a lot, so I want to try, and then this time with those 3 questions, hopefully you got the right answer. Okay, pause the video. It will take about 10 minutes, so try that. Okay class, let's compare your in-class activities 3 and 4, and hopefully you got the same answer. So how was it? Was it pretty fun? Getting better? And there's one more waiting, so make it yours. It's one more time, you can do it. So compare the answer. My rate of change turned out to be this one. You can compare my work here. And then as taking h as a 0, my derivative function is -1 over x squared. Then I want to find the function at 3. So I actually graph my function 1 over x and x is equal to 3. I'm looking for my tangent line at 3, this function. So when I plug in 3, I got slope as -1 over 9. And then by plugging the value of my original function, I got 3, 1/3 as this coordinate. So using slope and point, plug in point slope form, solving for mx plus b, I got my tangent line this. Hopefully you got the same answer. So let's check one more. You guys been practicing this big one last section, last chapter several times. There we go. So we've been preparing for this one. So now when you do rate of change, check one more time. You just need to be very careful first, this one step. If you do very careful about it, rest of them cancel out and turn out to be -4 over, so annoying. You don't see the bottom, right? I checked that. So from here, x plus h minus 3 times x minus 3. Basically, it's the same as this one. Sorry about that. So I copy one more time. Your rate of change is this. And then sending h 0, so I get my derivative function as this guy. And make sure you write it as f prime of x or f derivative of x. Then did you find the equation? I got y is equal to -4x plus 7. If you got it, excellent. And let's check how do I get this one. So I want to find that x is equal to 2. So at the time, if I plug in, it passes into 2, -1 as a coordinate. And plug in this one into my derivative function, shows me that my slope will be -4. So that -4 will give me my slope intercept form, if you cannot say, I write it again. Y plus 1 is equal to negative 4 and x plus minus 2. So I change to mx plus b, then I get negative 4x plus 7. And good job. Another one is waiting, and I want you to do one more, and after this one, well, I think you are ready for the rate of change of the derivative, okay? So one more, pause it. Okay, so if you got to finish in class activity 5, let's check one more time, and if you got it, and we get to introduce all those function form of different way of approaching our rate of change using the common denominator, using conjugate, also straightforward using quadratic functions. So my rate of change is this one. By sending limit as h0, you see this h cancel out, so I'm going to have square root of x plus square root of x is 2 square root of x 1 over, and then equation I plugged in x as 4, then it gives me slope as 1 over 4 at that time, and then the point is gonna passing through 4 comma 2. 4 comma 2, where do I get 4 comma 2? I plug in here because that's the graph, right? So my graph is a 4 comma 2. Then what is the tangent line at that moment? I got 1/4 x plus 1. Did you get it, class? If you got it, woo, I'm so happy. And then I hope that I get to see your reaction, but too bad. But if you got it, excellent job. And I think I'm gonna put some quiz very similar to this one. Oh, actually your test coming, right? Similar to this one, so just keep practice, okay. Okay class, now we are on dessert of 2.2. So it's gonna be a little bit challenged. Let's talk about now next function. Before we get to see the quadratic function and then rational function, radical function, like a 1 over x function and square root of x function. Then what about when we have an exponential function? We haven't studied about exponential function. We saw like x squared function, we saw square root of x function, we saw 1 over x function, and then I put a little bit complicated ones. So this time, I want to study about 2 to the x, which is the exponential function. We want to estimate the value of a derivative of a 2 to the x at x is equal to 0. So let's graph and then see if we can fill it. If I want to graph the 2 to the x function, it's gonna be by plugging 2, 1, 0, negative 1, negative 2. We practiced beginning of this semester or last week. It's gonna pass through this. Then now I wanna find the derivative of 2 to the x at x is 0. I wanna find what is this slope will be. What is this slope will be? Because the x is at 0. Right? So what will this slope? With my graph, it looks like kind of a 1, a little bit less than 1. So we can approach algebraically, graphically, and numerically. So do you guys remember how do we approach algebraically? That was the rate of change. So again, let's put into our formula x plus h minus f over x over h. Then this case is going to be 2 to the x plus h minus 2 to the x over h. But what is our x value? X value is at 0. So we are going to have basically finding rate of change with this one. But however, when you look at this, can we solve this one? Look at, earlier we can do algebra to get rid of the h value, or somehow we did some algebra to find the rate of change. Now I want you to think about, is there a way that I can simplify? So one of the way I could do is 2x, h means 2h, right? And minus 2x over h. That's one of the way I can see. I could factor out 2 to the x and 2h minus 1 over h. However, do I know what I should do about this part? Can I make it h goes away? if I plug in here, it's not gonna work. So that's why before we manipulate our equation by multiplying, conjugate, making common denominators. However, this case, I cannot get rid of this part. So what we having a problem in this case is we cannot solve exponential function algebraically. We cannot approach algebraically because we got stuck here, and with the information we know of a limit, we cannot go any further. So how we gonna find this? Then we have to keep studying here. So when you see that we wanna estimate this, which was 2x plus h minus 2x over h. However, we know that x is 0, so if I want to find graphically, that's all I can get. Only last way that we can find the slope is by plugging numerically. Then where should we plug in? Where should we plug in? We need to plug in here, but don't forget, this time what is the x value? I want to find when x is 0. So the function I'm going to numerically estimate will be 2 to the 0th power plus h minus 2 to the 0th power over h. Why? Because I'm looking around x is equal to 0. Then Yana, what if I'm looking at my rate of change, which means I want to find the slope around 2 here. Then you're gonna plug in 2 to the x value. This time I don't want to plug in 2 because these 2 are very confusing. So what if I want to find the rate of change at 3? Then yes, you are going to put your function 2, 3 plus h minus 2 to the 3rd power over h. And you have to plug in h value small enough so that you can find where that slope looks like. That's when x is equal to 3. So that's that part. I want to find slope x is equal to 0. So this is when x is equal to 0. So now I want you to pause and then plug in your equation. If you simplify this one, do you see that 2 to the 0th power is 1, right? So, or you can rewrite this one is the same as 2 to the h minus 1 over h. That's all I need to plug in. So I can write it 2 to the h minus 1, that's how I'm evaluating. Now plug in each value very small enough so that where the number goes around 0. So pause it and then plug in numbers. Let's compare with me. Let's continue numerical approach of the finding the limit of the derivative of a 2 to the x function. So as we mentioned, we cannot solve this one algebraically. We didn't learn any math. So that's we cannot continue algebraically. Then graphically, when I see it, it's about looks like a little bit less than 1 as a slope. So I actually put it into rate of change and around 1. Rate of change, I want to find that value around 1. So instead of x, I plug into 1. So as you see, I plug into, instead of x, I plug into 0. Then after you simplify, I have a 2 to the h minus 1 over h. And punch into calculator carefully, I got these values. So from the left-hand limit of x approaches from 0 minus, I see that my values are 0.662 going 0.69. And then plug in right limit of the x approaches from 0 plus, I got 0.69 and then 0.71. You see why getting bigger? Because whenever it goes here, you see your slope is getting bigger and bigger. That's why it gets bigger. So I want to actually have a little bit better number that I plug in 0.00001. Then it shows me the number is going to be actually look like slope as 0.693. So as you see, these numbers are getting closer. And then do you guys see, I'm gonna relate it to AI. The numbers are merging closer to 0.69, and then with all those testimony and then trying all the testing and experiment, they see that their number, whatever is going to be, converge into that number around 0.693. So I can conclude that the slope is about 0.693 at 0. At 0. Then I want you to do one more time. This time you are going to use sine function as in class activities, and I want you to estimate what will be the sine function slope around 0. So same format, do it, think about it algebraically, graphically, and numerically, and compare the answer with me. So class, how you feel? Now we are on last one of in-class activities. Do you following the logic one by one, okay? And then see that it's accumulating one by one. Keep watching video of mine. Calculus is actually really hard to learn without watching videos, right? So keep watching. And when I try to approach algebraically by plugging rate of change, I got this function. However, I see that when limit goes to h is 0, I cannot simplify. So I plug in x is 0 and try to approach other way of canceling x as 0. Then still it becomes sine h over h when I try to sending limit. I still get stuck with denominator h, so that I cannot solve algebraically. So now we have to approach it graphically or numerically. How are we gonna approach graphically? We know the sine function, so I graph sine function. At 0, my function will be, looks like linear equation this way. But I cannot really get much information besides it passing through 0, 0. So now I'm going to plug in numerically in function, and then I'm sending my x value closer to 0 minus in here, and then also I'm sending x value close to x plus here by plugging 0.1, 0.01, and this one I plug in 0.01, 0.001, like that. Then as you see my slope, this is actually slope formula, that is rate of change. I just simplify, and as you see that around x goes to 0, my function of sine x slope is going to be around 1. So actually slope at 0 of the sine function is exactly 1 in mathematics, and we will learn that later again. But we also learn about now this value, right? And later on you can also see how we can find the maximum values in next after the test. So this is it for chapter 2 of 2.2, and I went over a little bit slowly. It's gonna be a long video, and good luck catching up, and there are lots of in-class activities, so make sure you can do it, and hopefully when you have a test it's gonna be similar questions, and hopefully you get the correct answer. Okay. Thank you.